Let's go through some DP-203 exam questions, guys. To ace the certificate exam, make sure you get 23 questions or more out of these 25 questions. Quickly before we get started, thank you very much to my 5 new subscribers. If you're watching this, I know we will ace these exams together. Thank you, guys. Question 1. You're planning a solution to aggregate streaming data that originates in Apache Kafka and is output to Azure Data Lake Storage Gen 2. The developers who will implement the stream processing solution use Java. Which service should you recommend using to process the streaming data? The question is to do with technology for real-time streaming processing in Azure. On the screen, we are showing the technology options and their general capabilities as well as integration capabilities. And from here, we can already see that we can roll out Azure Event Hubs and Azure Data Factory from the options. Just going over them really quickly, Azure Event Hubs is used to ingest streaming data. It's more of a front door to events. Azure Data Factory is used to orchestrate data flow. And out of these technology options that we see on the screen, what we're interested in these two columns, Azure Stream Analytics and Azure Databricks. And first of all, looking at the programmability, we can already see what the answer is. Databricks is the one with the Java capability, and Azure Stream Analytics is only capable with SQL and JavaScript. Let's go down the Databricks column to just make sure the rest of the story fits as well. So as an input, we're using Kafka. If you read the question again, and indeed we can see that in the input row, and going down to the sink, Azure Data Lake Stores is there as well. So yep, we're good, and the answer is D, Azure Databricks. Question 2. You plan to implement an Azure Data Lake Storage Gen 2 container that will contain CSV files. The size of the files vary based on the number of events that occur per hour. File sizes range from 4 kilobytes to 5 gigabytes. You need to ensure that the files stored in the container are optimized for batch processing. What should you do? So the question is to do with best practice for using Azure Data Lake Storage Gen 2. So right now we have a lot of small files here, but in general, it's better to organize the data into larger files. That does not only lead to better performance, but also it reduces cost of storage as well. But some engines and applications, of course, might have trouble processing some really big files. So the rule of thumb is to stay between 250 megabytes to 100 gigabytes. The option that achieves our goal is D, merge the files. Question 3. You store files in an Azure Data Lake Storage Gen 2 container. The container has the storage policy shown in the following exhibit. Use the drop-down menus to select the answer choice that completes each statement based on the information presented in the graphic. So looking at the options here, we can see that it's to do with storage tier. So like the archive storage, cool storage, and hot storage. In fact, for this question, we don't really need to know what each of them do. We will look at them further in future questions. So this question is more to do with reading the policy. So if we look at the highlighted sections there, we can see that the files are being moved to cool storage. And looking at the second highlighted section there, the storage policy is being applied to the CSV files called contoso in container 1. Question 4. You're designing a financial transactions table in an Azure Synapse Analytics dedicated SQL pool. The table will have a clustered column store index and will include the following columns. Transaction type with 40 million rows per transaction type, customer segment 4 million rows per customer segment, transaction month 65 million rows per month, account type 500 million rows per account type. You have the following query requirements. An analyst will most commonly analyze transactions for a given month. Transactions analysis will typically summarize transactions by transaction type, customer segment, and or account type. You need to recommend a partition strategy for the table to minimize query times. On which column should you recommend partitioning the table? Partitioning, as you may already know, is a way of dividing the data for our usage pattern. if we divide the data into categories that make sense for us to use, then it can help improve the performance of the queries. So I think going through this question is a perfect example here. So looking at the query requirements, analysts will most commonly analyze transactions for a given month. So it makes sense that when we carry out our queries, what we want to do is to grab the data for each month. So this tells us that transaction month is the ideal column to carry out our partitioning on. And let's go through the rest of the question just to make sure that that is the case. Because another important thing about partitioning is that we don't want to over partition or under partition. So looking at our questions here, for each of these columns, they all have quite reasonable number of rows to apply the partition on. Not knowing about their distribution decision on this table, it's hard to decide just with those numbers. So we will just assume here that the numbers look all good for each column. So as previously established, the correct answer here is D, transaction month. Question 5. You have an Azure Data Lake Storage Gen 2 account named Account 1 that stores logs as shown in the following table. You do not expect the logs will be accessed during the retention periods. You need to recommend the solution for Account 1 that meets the following requirements. Automatically deletes the logs at the end of each retention period. Minimizes storage costs. What should you include in the recommendation? This question is to do with blob storage tier. So let's go through what the available storage options are and explain how they're different. The good thing about it is it's quite intuitive. So there are 3 storage tiers: hot, cool, and archive. So going through them one by one, in the hot storage, it's expensive to store our data there, but very cheap to query from there. Cool storage, it's about medium storage cost and medium query cost. And archive storage, it's very cheap to store there, but expensive to query there. For cool storage and archive storage, it's not like we can just store there and delete it and whatever we want to do anytime. So they both have minimum storage periods. For cool it's 30 days and for archive is 180 days. So it's really about asking how often we're gonna use this data, and that can tell us which storage option we should be using for that data. So now that we know this, let's go back to our question. Let's look at our requirements here. We want to automatically delete the logs at the end of each retention period. So for application is 360 days, infrastructure and 60 days. And since the cool storage has 30-day minimum storage, in theory, we can use cool storage for both of them. However, in the next requirement, it says we should minimize the storage costs. And looking at the application there, we can use the archive storage because the retention period is more than 180 days, but we cannot use it for infrastructure. So for infrastructure, we should use cool storage, and for application, we should use archive storage. And the second part of the question asks, how do we delete these logs automatically? This is one of those things we just have to kind of just remember. So the way we do this is using Azure Blob Storage Lifecycle Management Rules. Question 6. You plan to ingest streaming social media data by using Azure Stream Analytics. The data will be stored in files in Azure Data Lake Storage, and then consumed by using Azure Databricks and Polybase in Azure Synapse Analytics. You need to recommend the Stream Analytics data output format to ensure that the queries from Databricks and Polybase against the files encounter the fewest possible errors. The solution must ensure that the files can be queried quickly and that the data type information is retained. What should you recommend? The question is to do with data compatibility with Azure services. So with Databricks, any of the data format in the option is compatible. However, with Polybase, there are only 2 options that are compatible. Those are JSON and Parquet. So we have narrowed down our options here. And the question also says the solution must ensure that the files can be queried quickly. And for that, we don't want to use JSON, we want to use Parquet. So the correct answer here is B, Parquet. Question 7. You have an Azure Synapse Analytics dedicated SQL pool named Pool 1. Pool 1 contains a partitioned fact table named DBO sales and a staging table named STG sales. That has the matching table and partition definitions. You need to overwrite the content of the first partition in DBO sales with the content of the same partition in STG sales. The solution must minimize load times. What should you do? So there are three things we can do with partition tables: partition deletion, partition merging, and partition switching. And for this question, we're interested in partition switching here. And when we switch partition, we always want to go from source to target. And in our case, the source is the STG sales table, and the target is the fact table, which is named DBO sales. So what we need to do here is switch the first partition from STG sales to DBO sales. So the correct answer here is C. Question 8. You are designing a slowly changing dimension for supplier data in an Azure Synapse Analytics dedicated SQL pool. You plan to keep a record of changes to the available fields. The supplier data contains the following columns. Which three additional columns should you add to the data to create a type 2 SCD? This question is about slowly changing dimension, so it's important to understand what that is and different types of them. So slowly changing dimension is to do with dimension table. So if you think of like a dimension table, maybe dimension supplier, you might have like supplier name with supplier category column as well. Say if a supplier changes their service from fishing supplies to, say, tennis supplies, then of course the dimension table needs to be updated, and different types of SCD determine how the update is carried out. There are main three types of SCD, type 1, type 2, and type 3, and let's go through them one by one to see what the differences are. So on the screen I'm showing you the type 1 SCD. So we have a supplier dimension table here, and Sally is changing her supplier category from fishing to tennis. So with type 1 SCD, it's important to notice that the change is made directly and no historical value is recorded. And the only thing changing is the modified date. So we can see that in the second table, which is the updated table, we can see that her current supplier category is tennis, but we don't know what her last one is. So looking at the type 2 SCD, we can see that it's got new columns to type 1 SCD. So we have the start date, end date, and its current column. So start date and end date indicate when the given information on the row is effective. So currently it started being effective from 23rd of August to basically forever for now. But when her supplier category changes, a whole new row gets added with the new supplier system ID. So if you look at the updated table, we can see that for the fishing row, the end date has changed and its current is to false, and the third row is the new information. So comparing to type 1 SCD, a whole new row is added, as well as keeping track of what the historical values were. Lastly, looking at type 3 SCD, there are again new columns here. We have current supplier category, original supplier category, and similar to type 1 SCD, inserted date and modified date. When Sally's category changes, of course, her original supplier category is fishing, and now her current category is tennis. So those two get recorded in each respective columns, and the modified date changes as well. So type 3 SCD can be thought of as adding columns to track the changes, and type 2 SCD can be thought of as adding rows to track the changes. There are some other types of SCD as well, like type 6, but that type is a combination of type 3 and type 2, and the important types that we need to know are type 1, 2, and 3, so we'll stop it here. So going back to the question, we're interested in adding additional columns to create a type 2 SCD. So if you remember what type 2 SCD is, it's adding a new row. So for that we needed effective start date, effective end date, and surrogate primary key. So the correct answers here are A, B, and E. Question 9. You have a Microsoft SQL Server database that uses a third normal form schema. You plan to migrate the data in the database to a star schema in an Azure Synapse Analytics dedicated SQL pool. You need to design the dimension tables. The solution must optimize read operations. What should you include in the solution? So this question is to do with how we organize data. So there are two schemas of interest in this question. The first schema being normalization form schema and the second one being star schema. And we need to understand both of them to answer these questions. And we're not going to go into detail on each of these schema, and we're just going to introduce the basic idea behind them. So with the normalization form schema, the main idea is to manage the data inconsistency, complexity, and redundancy. As your forms higher, second or third normalization form schema, you introduce more rules in order to make your data consistent, less complex, and less redundant. But of course, there are always pros and cons, as always. So going up the schema, so we call it normalization. Yeah, sure, you're getting rid of inconsistency, complexity, and redundancy. But because there are more rules, reading data will take longer. However, writing to data will take less. Whereas, of course, it works the other way as well. If we denormalize our form, so we are going down our normalization form, then we are potentially introducing some data inconsistency, but reading data is much faster, writing data is a bit slower. And reading the question here again, second to last sentence, the solution must optimize read operations. So we're looking at denormalization. So currently it's at third normal form, and in order to speed up the reading process, we want to denormalize to a second normal form. And the second part of the question is about star schema. So in the star schema, there are fact tables and dimension tables. So the dimension tables contain information about business attributes. You might have something like customer ID with customer name and their email address and so on. And the fact tables contain observations about those business attributes. Like maybe there's a transaction fact table which shows who made the transaction and to which customer and how much was involved and so on. And these tables are linked by these IDs. So when I make sales to a customer, in the transaction fact table, the customer ID will be recorded on that corresponding transaction row. And the customer dimension table can be joined through that ID. So the really important part here is that for dimension tables, we have unique numbers to each row. If we have same number for two different customers, then there will be a clash and the transaction doesn't make sense anymore. So the correct answer here is new identity column, which assign unique numbers to each row. Question 10. You plan to develop a dataset named Purchases by using Azure Databricks. Purchases will contain the following columns: product ID, item price, line total, quantity, store ID, minute, hour, day, month, year. You need to store the data to support hourly incremental load pipelines that will vary for each store ID. The solution must minimize storage costs. How should you complete the code? Looking at our code here, we first know that following the write, we first know that we want to partition the table. So the first box is pretty easy. So .partition by is the correct answer. And the second box is basically asking, okay, what do we partition by then? Looking at the question again, we know that we want to support hourly incremental load pipelines. So it is easy to think that the second option is the correct answer, store ID hour. But if you were to choose that, then it's of course partitioning by store ID and hour. And because hour gets repeated every day, so hour 1 to hour 24, though it will be partitioned that way rather than each unique hour as the time passes gets partitioned. So the way to do it is to of course have the hours and get it distinguished by the day and by month and by year. So the correct answer in the second box is the third one. And lastly, we know that we want our solution to minimize storage costs. And the command that satisfies that is parquet. Question 11. You're designing a partition strategy for a fact table in an Azure Synapse Analytics dedicated SQL pool. The table has the following specifications. Contains sales data for 20,000 products. use hash distribution on a column named product ID. Contain 2.4 billion records for the years 2019 and 2020. Which number of partition ranges provide optimal compression and performance for the clustered column store index? This question is about best practice for partitioning as well as understanding distribution. So even though a table might appear just as one, when it's distributed, it's actually spread across 60 distributions. So 60 is the magic number here. So we have a table with 2.4 billion records. If we divided that by 60, we get 40 million. So we know that each distribution has 40 million rows. So the partition works for each of these 40 million. 1 million rows is like the ideal number of rows to partition, as that indicates that we are not under partitioning or over partitioning. So doing some crazy maths here, the correct answer here is 40. Question 12. You are creating dimensions for a data warehouse in an Azure Synapse Analytics dedicated SQL pool. You create a table by using the Transact-SQL statement shown in the following exhibit. Use the drop-down menus to select answer choice that completes each statement based on the information presented in the graphic. So the question is about the syntax to create tables, especially a dimension table, as well as the recognizing which type of slowly changing dimension it's using. Looking at the query here, we see that it's a dimension table for products. So even though there are columns like cell start date and cell end date, we shouldn't be confused that with effective start date and effective end date, which would have suggested that this table is a type 2 slowly changing dimensions, but that's not really the case here. So looking at the table again, we see that there is no columns that records historic data. So this suggests that this is a type 1 SCD. And the second part of the question asks what type of column is the product key column. Looking at that row with product key in that syntax, there's like an identity 1,1. What that does is it assigns unique number to each row. So the product key column is a surrogate key. Question 13. You are designing a fact table named fact purchase in an Azure Synapse Analytics dedicated SQL pool. The table contains purchases from suppliers for a retail store. Fact purchase will contain the following columns. Fact purchase will have 1 million rows of data added daily and will contain 3 years of data. Transact-SQL queries similar to the following query will be executed daily. Which table distribution will minimize query times? So the question is about understanding distribution. When a table is distributed, even though a table looks like just one table, it's actually spread across 60 compute nodes. And the way it's split into these compute nodes is determined by which distribution we're using. So there are mainly 3 types: hash, round robin, and replicate. And we'll go through them briefly to see what the differences are between them. So hash and round robin are quite similar, so we'll go through them first. So for hash distribution, the way it distributes the table improves the query performance for larger tables. So it's mainly used for large fact tables. Looking at round robin distribution, the way it distributes improves the loading speed. So this distribution is usually used for staging tables. So the last remaining distribution is replicate distribution. So as the name suggests, what it does is it replicates the table in each compute node. As the name suggests, replicated distributions copies the table into these 60 compute nodes. So the whole table is copied into these compute nodes. When we use the table to say join, there's no need to reshuffle between these compute nodes, so the query is a lot faster. But obviously the downside of it is because we are replicating these tables, there could be a storage issue if the table is too big. So the replicated distribution is mainly used for small dimension tables. So for you guys, the only thing you have to remember is hash distribution, large fact tables, round robin distribution, staging tables, and replicate distribution, dimension tables. So going back to the question here, we are dealing with a fact table. So we know that the distribution should be a hash distribution. That narrows down our options here. So the question is, should the hash distribution be on purchase key or date key? So choosing which column hash distribution should be applied on. There are mainly 3 rules to decide which column the hash distribution should be applied on. The 3 rules are: there should be many unique values in the column, there should be none or very few nulls, and it shouldn't be a date column. So applying that to this question here, the correct answer here is B, hash distributed on purchase key. Question 14. You are implementing a batch dataset in the Parquet format. Data files will be produced by using Azure Data Factory and stored in Azure Data Lake Storage Gen 2. The files will be consumed by an Azure Synapse Analytics serverless SQL pool. You need to minimize storage costs for the solution. What should you do? We can already rule out a couple of options here. So B, use open row set to query Parquet files. It's about querying, so we can rule that out. C, create an external table that contains a subset of columns from the Parquet files. Creating an external table doesn't really affect our current storage situation here, so we can rule that out as well. So the remaining options are A and D. And Azure recommends that Parquet files are stored with snappy compression, which happens to be the default compression as well. So the question is a little bit confusing, but Parquet files with snappy compressions store data in a columnar format, is compressed, and is highly optimized with Spark. So the correct answer here is A. Use snappy compression for files. Question 15. You need to build a solution to ensure that users can query specific files in an Azure Data Lake Storage Gen 2 account from an Azure Synapse Analytics serverless SQL pool. Which 3 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. So this is about creating an external table from an Azure Synapse Analytics serverless SQL pool. So, sorry guys, but there's no really other ways to answer this except just to memorize how it's done. So there are 3 steps. First is to create an external data source. Second is to create external file format. Third is to create external table. Question 16. You are designing a data mart for the human resource department at your company. The data mart will contain employee information and employee transactions. From a source system, you have a flat extract that has the following fields: employee ID, first name, last name, recipient, gross amount, transaction ID, government ID, and so on. You need to design a star schema data model in an Azure Synapse Analytics dedicated SQL pool for the data mart. Which 2 tables should you create? Each correct answer presents part of the solution. So this question is about understanding star schema. And we mentioned briefly before, star schema is just a way of organizing our data. There are 2 types of tables in star schema: fact table and dimension table. And dimension table has business attributes, and fact table has observations of these attributes. Going through this question is perfect to get an example of this star schema. So the second sentence of the question says the data will be employee information and employee transactions. And employee information will be like a dimension table because it's a business attribute, and employee transactions will be a fact table. So let's see with the given fields if that makes sense with our understanding of fact and dimension tables. So on the screen are all the fields here, and if we split them into 2 according to the fact and dimension definitions, looks something like this. From there we can create a fact table and a dimension table that looks something like this, and we can see that these tables are linked together through the employee ID column. So the correct answers here are C, a dimension table for employee, and E, a fact table for transaction. Question 17. You are designing a dimension table for a data warehouse. The table will track the value of the dimension attributes over time and preserve the history of the data by adding new rows as the data changes. Which type of slowly changing dimension should you use? So this question is about understanding SCD types. I think you all must be experts by now. So the question says the history is preserved by adding new rows as the data changes. And there's only one type of SCD that adds new rows, and that is type 2. So the correct answer here is C. Question 18. You are building an Azure Synapse Analytics dedicated SQL pool that will contain a fact table for transactions from the first half of the year 2020. you need to ensure that the table meets the following requirements. Minimizes the processing time to delete data that is older than 10 years. Minimizes the I/O for queries that use year-to-date values. How should you complete the Transact-SQL statement? The question is about understanding create table syntax here. And if you look at the syntax range right for values, it's used with partition. So that's answered the first part of the question. The second part of the question is which column should the partition be applied on? And reading the question, we see that the query performance is to do with the data that is older than 10 years, and a lot of queries that use year-to-date values. So the correct answer here is transaction date ID. And the last part of the query confirms that. You can see that in the brackets, there are date IDs in there. Question 19. You are performing exploratory analysis of the bus fare data in an Azure Data Lake Storage Gen 2 account by using an Azure Synapse Analytics serverless SQL pool. You execute the Transact-SQL query shown in the following exhibit. What do the query results include? So the question is about accessing external data from serverless SQL pool. The question is pretty straightforward as long as we understand the syntax. So the important part here comes after from open row set bulk. And comparing it to the model syntax that's shown on the screen, we see that the following bulk is our data file of interest, which in this case is CSV bus fare trip data 2020 asterisk. So the asterisk is the key point here. So what that does is it selects all the CSV files that starts with trip data 2020 that's in the CSV/bus fare directory. So the correct answer here is D. Only CSV that have file names that beginning with trip data 2020. Question 20. You plan to create an Azure Databricks workspace that has a tiered structure. The workspace will contain the following 3 workloads. A workload for data engineers who will use Python and SQL, a workload for jobs that will run notebooks that use Python, Scala, and SQL, a workload that data scientists will use to perform ad hoc analysis in Scala and R. The enterprise architecture team at your company identifies the following standards for Databricks environments. The data engineers must share a cluster. The job cluster will be managed by using a request process whereby data scientists and data engineers provide packaged notebooks for deployment to the cluster. All the data scientists must be assigned their own cluster that terminates automatically after 120 minutes of inactivity. Currently, there are 3 data scientists. You need to create Databricks clusters for the workloads. Solution. You create a standard cluster for each data scientist, a high concurrency cluster for the data engineers, and the standard cluster for the jobs. Does this meet the goal? The question is about Databricks cluster modes. There are 3 Databricks cluster modes: standard, high concurrency, and single node. We'll first go through what the difference is between standard and high concurrency here and go over what single node is quickly. So the standard cluster is mainly recommended for a single user, whereas the high concurrency cluster is recommended for collaborative work between a group of people. And for standard cluster, the compatible languages are Scala, R, Python, and SQL. Whereas for high concurrency cluster, the compatible languages are all that except Scala. And for standard clusters, they terminate after 120 minutes of inactivity, whereas high concurrency clusters don't have any auto termination there. And the single node cluster is very similar to the standard clusters, but it's for small amount of data. So we'll go back to the question here. The solution suggests standard clusters for each data scientist. For data scientists, the requirements are all the data scientists must be assigned their own cluster that terminates automatically after 120 minutes of inactivity. And they use Scala and R. So standard cluster will be a good cluster for them. And the solution also suggests using high concurrency clusters for data engineers. So the requirements are data engineers will use Python and SQL. Yeah, that's good. And reading through, the data engineers must share a cluster. So that's also good. So that looks promising as well. And lastly, the solution suggests we use a standard cluster for the jobs. And reading the requirements, a workload for jobs that will run notebooks that use Python, Scala, and SQL. Good. The job cluster will be managed by using a request process whereby data scientists and data engineers provide packaged notebooks for deployment to the cluster. So that's fine as well. So the correct answer here is yes. So we have the exact same question here, except that solution is now standard cluster for each data scientist, high concurrency cluster for data engineers, and a high concurrency cluster for the jobs. So the only difference is that before we were using standard cluster for the jobs, now we're suggesting high concurrency cluster for the jobs. This won't work here because the jobs will run notebooks that use Python, Scala, and SQL. Python and SQL are supported on high concurrency clusters, but not Scala. So the correct answer here is B, no. Question 22. You plan to create a real-time monitoring app that alerts users when the device travels more than 200 meters away from a designated location. You need to design an Azure Stream Analytics job to process the data for the planned app. The solution must minimize the amount of code developed and the number of technologies used. What should you include in the Stream Analytics job? So with Azure Stream Analytics, we can integrate real-time IoT streaming. So for the first part of the question, the input that we want is stream. And within Azure Stream Analytics, there's a built-in geospatial function. So use case is exactly this. What we can do with that is we can install GPS in the device so that when it travels away from a designated location, we get an alert. So in the second part of the question, the correct answer here is geospatial. Question 23. A company has a real-time data analysis solution that is hosted on Microsoft Azure. The solution uses Azure Event Hub to ingest data and an Azure Stream Analytics cloud job to analyze the data. The cloud job is configured to use 120 streaming units. You need to optimize performance for the Azure Stream Analytics job. Which two actions should you perform? Streaming units represent computing resources to execute the Stream Analytics job. So as you can imagine, the more streaming units we have, the more improved the performance is. So one of our answers is D, scale the SU count for the job up. But of course, there is a limit to how many streaming units we can have. So there is a max cap for that number. The max cap for that number is 6 streaming units per partition. So our first answer is generally correct as long as we haven't met the max streaming units already. So it naturally leads to our next action to optimize the performance here. We can implement the query parallelization by partitioning the data input. So the correct answers here are D, scale the SU count for the job up, and F, implement query parallelization by partitioning the data input. Question 24. You have the following table named employees. You need to calculate the employee type value based on the hire date value. How should you complete the Transact-SQL statement? This question is about understanding the case, when, else, and syntax in the Transact-SQL. So on the screen you can see the model syntax example, and comparing it to our SQL query, we can see that the missing squares should be case and else. So the way it works is quite intuitive. So we start with the case and end with end, and when hire date is greater than or equal to 2019 1st of January, then this our new column here, employee type, is new. Else, so otherwise, it's standard. Question 25. You have data stored in thousands of CSV files in Azure Data Lake Storage Gen 2. Each file has a header row followed by a property, formatted, carriage, return, and line feed. You are implementing a pattern that batch loads the files daily into an Azure SQL data warehouse by using Polybase. You need to skip the header row when you import the files into the data warehouse. Which 3 actions should you perform in sequence? The question is about accessing external data from a SQL server. Just like creating external table on a serverless SQL server, we just have to remember these steps. So sorry guys, but we just have to remember it for the certificate. The good thing about it is the steps are quite similar, the steps for creating an external table. The first step is to create a database scoped credential for Azure Blob Storage. The second step is to create an external data source, and the third step is to create an external file format. So looking at our options, our first step again mentioned is to create a database scoped credential that uses an OAuth, 2 token, and a key. And the second step is to create an external data source. And we can see that there's two data source options. One option, external data source, that uses the ABFS location, and the other one that uses the Hadoop location. In our case, the data is stored in Azure Data Lake Storage Gen 2. So we go with the ABFS location. If the question were to say it's stored in Azure Blob Storage, then we will go with WASB. And finally, we create a file format and set the first row option. Thank you very much for watching till the end. Check out my other videos for more questions on DP-203. Let's ace these exams together.